Hello everyone, welcome to this video. In this video we shall be looking at the next two questions from exercise 9.2. So let's start with question number 11 here. So in this question here, the question here says that if the sum of first PQ terms, PQ and R terms of an AP, they are given to be A, B and C respectively, then we need to prove that A upon P into Q minus R plus B upon Q into R minus P plus C upon R into P minus Q, that is equal to 0, right? This is the question here. So in this question, we are given that the sum of first P terms is A, the sum of first Q terms is B and the sum of first R terms is C, right? And we know the formula for calculating the sum up to first n terms, that is given by n by 2 2a plus n minus 1d, right? So now using this formula onto the first given relation, the sum of P terms is equal to A. So replacing here n with P, what do we have? We have S of P as P by 2 2a. Now here notice that this is your first term, and here the sum is given to be small a. So that means we cannot use small a here to represent our first term. So here capital A represent the first term of the given AP, right? So let's denote that by capital A to differentiate between this A and this A, right? Okay. So this is capital A here plus in place of n we are writing P minus 1 into dd is the common difference, and this is given to be A. Otherwise if you write this as also small a, then both of these things they become equal, however they are different, right? So similarly we'll write this for SQ and for SR, right? For SQ it would be Q upon 2 2a plus Q minus 1d, that is given to be B, and for SR it is given to be R by 2 2a plus R minus 1 times of d, this is given to be C. So let's mark this as equation 1, equation 2 and equation 3. So here we wanted to prove this thing. So here can you see the term A upon P, B upon Q, C upon R in our equation 1, 2 and 3. So if you move this P to this side, you would have A upon P. If you move this Q to another side, you would have B upon Q, and if you move this R to the another side, you would have C upon R. So that means we have these three terms. Now in our expression we also have Q minus R multiplied to this thing. So that means if we multiply whole of the equation 1 with Q minus R, we would have our first term, and if we multiply whole of the second equation with the term R minus P, we would have our second term here, and if we multiply P minus Q with the whole of the equation 3, we would have our third term here. So that would give us one side of the equation, and solving the other side would simply give us 0. So let's see, is it the case? So what we are doing, we are simplifying this thing, we are shifting this P onto the other side so that we have these things, and then multiplying this 1 by 2 inside the brackets, right? So that in this case the first term would be just A plus P minus 1 d by 2, right? Similarly for all the three equations. Now here what we are doing, for equation 4 we are multiplying by Q minus R, equation 5 by R minus P, and equation 6 by P minus Q, and adding them all, so that our right hand side would just be the expression that we want, and our left hand side would be the expression which we require as 0 in order to reach at our result. So we need to solve this thing in order to show that it is 0, right? So basically what do we have? We have whole of this thing multiplied with Q minus R, this is it. Another whole of this thing multiplied with R minus P, this is this thing, and whole of this thing multiplied with P minus Q, this is this expression. So now what we can do, we can simplify the terms, we can collect all the terms in which A is appearing. So you see the terms of capital A, they are collected. So capital A is coming here, the coefficients are Q minus R, so I have written down it here. Here A is appearing, so the coefficients here are R minus P, so these are the coefficients here, and A is appearing here, so the coefficients here are P minus Q, so I have written it down here, right? And similarly I have collected all the terms which have d by 2 in common to them. So you see we have d by 2 here, so its coefficient is q minus r into p minus 1. So q minus r into p minus 1. Similarly, d by 2 is here, so its coefficient is q minus 1 into r minus p. So this is what I have written here. And d by 2 is here, so that means its coefficient is p minus q into r minus 1. So this is what I have written here. So now you see in this expression, this q and this q cancels with each other, this r and r cancels with each other, p and p cancels with each other. So that means this whole term becomes 0 and we can eliminate writing it. So it is 0 into a, which is nothing but 0. And so next what we need to do, we need to solve this expression. So that means we need to multiply the contents of d by 2. So d by 2, we can solve this thing, q minus r into p minus 1. It would be qp minus q minus rp plus r. Similarly, we can multiply these brackets and these brackets in order to obtain these terms, correct? Okay. So here, after solving this, you can see here very clearly that when you simplify the expression, this pq cancels with this pq, this q cancels with this q, right? This qr cancels with this rq, and because all of them have opposite signs, this pr and rp cancels with each other, this r and r cancels with each other, this p and p cancels with each other. So all the terms cancel out each other. So that means we are left with 0 times of d by 2, and 0 times of something is 0 only. So therefore this right hand side here becomes equal to 0, and this is what we wanted to prove here in this question. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.